Hello, today we are going to be practicing our work in algebra and we are going to be revising some of the stuff that we did in junior cycle. And we're going to start by how to multiply out terms and add up like terms. So we start here. We've got 2a sitting outside of a bracket, which means it is multiplied by each thing that is inside the bracket. And our minus a here is likewise multiplied by everything inside the bracket. And let's do that now. So we've got 2a and we're going to multiply it by 4. So 2, or first of all, plus multiplied by plus is plus. 2 multiplied by 4 is 8. And a multiplied by nothing is a. 2 multiplied by ak. 2 multiplied by 1 is going to be 2, plus 2. A multiplied by a is going to give us a squared, and we have k. 2a multiplied by minus 5a plus by minus is going to give us minus. 2 by 5 is going to give us 10. And a multiplied by a is going to give us a squared. Next, we have minus a multiplied by plus 3a. So minus multiplied by plus is going to give us minus. 1 multiplied by 3 is going to give us 3. And a multiplied by a is going to give us a squared. Minus a multiplied by minus ka minus multiplied by minus is going to give us plus. A multiplied by ka is going to give us k a squared. Minus multiplied by minus is going to give us plus. A multiplied by 7 is going to give us 7a. Our next job, now that we've done our multiplication, is to look for like terms. So if I start off on my left hand side, I've got 8a. Is there anything else that just is an a? And there is. There's plus 7a over here. Then I look at my next term, 2a squared k. Is there anything that is a like term with that? And there is. Ka squared is the same as a squared k, because I know that the order of multiplication doesn't matter. 3 multiplied by 2 is 6, and 2 multiplied by 3 is 6. So the order of multiplication doesn't matter. So these two terms are like terms. And then finally, I have 2a squared terms here. And you can see what I've done. I put a different symbol underneath each one of them. When we're doing higher level, we're going to be dealing with lots of questions where there's a lot of terms going on and we have to do a lot of things all at once. So having markers for like terms is going to be very important for us not making mistakes, and particularly mistakes with signs when we have a bunch of things going on. So if we add up our like terms now, we are going to have 8a plus 7a is going to leave us with 15a. 2a squared k plus 1a squared k is going to leave us with 3a squared k. I could have written that as 3k a squared if I preferred. And then minus 10a squared minus 3a squared is going to leave me with minus 13a squared. Now, in pretty much all circumstances, we're going to write the highest power first. Now, there's a bit of ambiguity here, but I'm going to start with minus 13a squared plus 3a squared k plus 15a, going from highest order or highest power down to lowest. And it's a very good habit to be in for doing our problems. It will help us a lot in the long run. Now, if I get into multiplying some larger brackets out, I have my first bracket here multiplied by my second bracket, and I'm going to take the first term in the first bracket, multiply it by everything in the second bracket, and the second term in my first bracket multiplied by everything in the second bracket. So let's write that out. X on 2x squared minus 7x minus 1, and then minus 7 on the same thing on the second bracket. And we are going to multiply that out. We're effectively back at the same position as we were in the previous question here. So I'm going to have x multiplied by 2x squared, x multiplied by minus 7x, and x multiplied by minus 1, and then minus 7 multiplied likewise. So I have 2x cubed multiplied by minus 7x squared, multiplied by minus x, minus 14x squared, plus 49x, plus 7. Now I'm going to group my like terms. I don't have anything else that it's x cubed, but I do have 2x squared terms, and I do have 2x terms. And I'm going to write my highest power first, as we discussed up here. So I have 2x cubed minus 21x squared plus 48x plus 7. Now there's something that I want to highlight. This is as far as we can go because we've run out of like terms, but there's something that I want to highlight to you here about the first term and the last term in my final answer. Let's see if we can see where they came from. The first term in my final answer came from multiplying the first term in the first bracket by the first term in the second bracket. We can see that here. X multiplied by 2x squared gives me 2x cubed. The last term comes from multiplying minus 7 by minus 1 gives me plus 7. The middle terms are combinations of more multiplication and addition and subtraction and so on. But the first term and the last term are simpler. They just come from multiplying the first term in the first bracket by the first term in the second bracket, and the last term in the first bracket by the last term in the second bracket. This is going to be important later on when we're multiplying out brackets for identities and for solving particular kinds of problems where we're looking for factors. So if we can remember this fact, it's going to help us with problem solving later on. Now, next thing I want to talk about is perfect squares. So we know what perfect squares are. I'll give you an example. 16 is a perfect square. Why is it a perfect square? Because I can say that it can be written as 4 squared. In algebra, the most basic form might be a squared. Could be a perfect square, or would be a perfect square, because it can be written as a by a, in the same way as 4 squared is 4 by 4. And if I had x plus 2 to be squared, that's a perfect square, and its multiplied out version is also a perfect square. So if I had x plus 2 multiplied by x plus 2. A faster way of multiplying out a perfect square is to remember a phrase or a rule. Square the first by the second and double it. So x by 2 is 2x and double it is 4x. And square the second plus 4. So square the first term, multiply the first by the second and double it, and square the second. And this can save us valuable time in an exam, and you're perfectly entitled to go from this line here to this line here in the exam. It's accepted that you might know that rule so that you don't get docked any marks or get into any difficulties from skipping from one line to the other. So if we can remember, square the first by the second and double it, square the second, that is going to save us some time in our algebra. So that we already know. We know about multiplying out brackets. We know what a perfect square means. We know all of this already. But what I want to highlight to you is something that might be a little bit less obvious, or which we might have forgotten in our mathematical work. And that's if we have something like this. So if we multiply this out, let's use our rule that we discussed about here. So square the first, so ax all squared would be a squared x squared. First by the second and double it would be 2abx, and square the second would be plus b squared. This is the general form of a perfect square. So this is an example of a perfect square because it's a multiplied out version of our bracket. It's a squared bracket, gives us this example of a perfect square. So this is a perfect square in the same way as 16 is, because it can be written as something squared. This is the general version. This is the general version of a perfect square. And we can use this general version to spot patterns in perfect squares that are going to help us. In junior cycle, you may remember something called completing the square, where we used exactly the same argument as we're going to go through now. But let's put this pattern that we've just multiplied out into practice and see if we can use it to solve a problem. If I have a quadratic expression like 9x squared plus kx plus 4, and I'm told that this is a perfect square, if I'm told that that is a perfect square, I can use that to find the value of k. Why? Because I know this pattern. If I know the two end terms here, I know the square root of them, the square root of a squared, multiplied by the square root of b squared, doubled, is going to give me the coefficient of x. So if I get the square root of 9, I get the square root of 9, which is going to be plus or minus 3. The square root of 4 can be plus or minus 2. I know that if I multiply these two things together, the square root of my two end numbers, and multiply that by 2, I must get the number that's in front of my x, the coefficient of my x, which is what I'm looking for. It's my k. So to find k, that's going to be 2ab from my pattern up here. So that's going to be 2 times a is plus or minus 3 multiplied by plus or minus 2. And I end up with plus or minus 12. So as it turns out, there's actually two values of k that would make this a perfect square. 9x squared plus 12x plus 4, and 9x squared minus 12x plus 4. This would factorize to 3x plus 2 to be squared, and this would factorize to 3x minus 2 to be squared. Let's double check that our pattern holds. Square the first, that checks out. First by the second, give us 6x, and double it is 12x, and square the second, 2 squared is 4, and likewise with my second term. Now there's something that I've used here which might jump out at people, because we often are a little bit lax with this in junior cycle, because it usually doesn't matter in junior cycle, but I've taken the plus or minus of my square root, because if I have x squared is equal to 25, to find out what x would be equal to, I have to get the square root of 25, but I have to get the plus or the minus of it. And why? Because if I had gone the other way, if I had started out with x is equal to 5 and squared both sides, I'd end up with x squared is equal to 25. Or I could have started out with x is minus 5, squared both sides, and gotten x squared is equal to 25. Both values of x will give me the same value of x squared. So when I am doing higher level mathematics at Leaving Cert, I'm going to have to take that fact into account fairly regularly. The fact that when I'm getting the square root of something, I could be dealing with the positive or the negative answer. This is going to be extremely important quite regularly. And you can see that it gives us two distinct answers here instead of only getting one. So this is what we need for our algebraic expressions for now.